this is the second video in the GCSE math series on vectors. In this video, I'll be talking about the properties of vectors. So, in the previous video, I introduced you to the concept of vectors. I discussed the difference between scalars and vectors, and I also provided you with this handy diagram which will help you remember the difference between scalars and vectors. I introduced you to different vector notations, and we also calculated the magnitude of vectors together. So in this video, I will introduce you to the addition and subtraction of vectors and also to the concept of parallel vectors. So, talking about addition of vectors, we use the triangle law of vector addition. So what that means is that if you want to go from vector A to vector C, we can take an indirect route which goes via B. So that way and that way. So that is the triangle law of vector addition. So we can write C equals A, because we follow A in the same direction as the arrow is drawn, given by this thing here, and then from B to C, which is given by vector B. Converse to the previous example, in the second example, what we have is A to B, which is the desired direction. However, B now acts in the opposite direction against our desired direction. So what we do is we flip it and give it a negative sign. So a good way to remember this is by looking at this diagram. So if it goes in the same direction, you just add the vectors as we did in the first example. However, if the direction needs to be changed, then we also change the sign. So when you change the sign, you change the direction. So for this example, if you want to get C, that would be A, because in the same direction as required, but you have minus B, unlike before. Moving on, here's more on addition of vectors. So here are the two other variants that you can have for the same example. So if you want to go from A to C again, unlike the previous two cases, A now acts in the opposite direction. So to have A to B, we will have minus A. So C is equal to minus A plus B, because B acts in the required direction. Okay, so it acts in this direction. If you want to go from A to C, so if you want to express C in terms of A and B, A to B would be minus A. Okay, A to B would be minus A, and then B to C would be minus B. And you can tell whether you need a positive or negative if you're going in the flow or against the flow. So this was against and against. So the actual direction was backwards and backwards. If you want to go against the direction of flow, then you flip the sign. Okay? So here's the diagram again to help us assess whether we have to change the sign and the direction or not. For addition of vectors, especially those expressed in column forms, we add or subtract element-wise. So this is the x component and these are the y components. So what we do is we add the x components because we've been told to add, and we also add the y components. When doing that, we get 6 and 7. Just normal arithmetic, nothing too hard. Likewise, for the second example, we add element-wise. So add the x elements, so that's minus 5 plus 3 in the top, and 7 minus 5. So here it's 7 plus minus 5, that makes it 7 minus 5. And that gives us minus 2 and positive 2. More on addition of vectors, especially those expressed in column form. As we said before, you add the x and y components together. So for this question given here, if you want to determine a plus b as the question asks you to do so, you have a plus b. So again, add element-wise. So that's 6 minus 3 plus minus 3 and 3. That gives us 3 at the top and 0 at the bottom. You add element-wise. Similarly, for the second part, a minus b, you've got to be careful with the signs here though. You have 6 minus minus 3. Minimize mistakes by having brackets here, and then for the y component you have minus 3 minus 3, and that gives you 9 and minus 6. Moving on, when talking about parallel vectors, you know vectors are parallel if they have the same component. So if you've got a and a, you know that these two vectors will be parallel. And you can add the parallel vectors just like algebra. So add 3a plus a to give you 4a. You know that vectors 2c and 5d are not parallel because they have different components. You know that 5d and 2d are parallel because they have the same component d. Likewise, vectors 2d and minus 2d are also parallel. However, they act in different directions. A more precise word to use here is opposite direction. So these two vectors act in opposite directions. So if we define this to be positive, as we've done here, by assuming that this was indeed positive, because this arrowhead is now in the opposite direction, you know that it must be negative. So if you define one side to be positive, the other or the opposite side is naturally negative. So I hope you found this video useful. Please consider subscribing to my channel for more educational videos.